Okay, in this video, we're going to be looking at how to solve the absolute value inequality greater than case. You see that we're presented here with the absolute value of 2x minus 3 is greater than 5. And before we go into the setup that was suggested earlier in the lesson, I want to discuss why we're going to set this up as an OR case. If you disregard just momentarily the expression that's inside of here, you're basically just looking at an expression that says, what can you take the absolute value of that is greater than 5? And if you look at this number line, you notice that anything that is on the right side of the number 5, such as 6, 7, 8, 9, any of those numbers, if you take the absolute value of any of these numbers, you're going to be greater than 5. So when we do set up this problem, we're going to state that this is satisfied, this particular condition of your value having an absolute value greater than 5 if you're over here. Anything beyond 5, anything to the right or greater than 5. Also take notice that the absolute value of any of these values is also greater than 5, because when you take the absolute value, it becomes positive as it is associated with distance. So for instance, -6, the absolute value -6 is greater than 5. Absolute value of -7, if it was in here, would be greater than 5. So any number out in this area all the way to -infinity would also satisfy this condition of having an absolute value greater than 5. And that kind of lends itself to why we are setting this up as an OR case. This quantity, or in other words, the value inside of here, could be anything in this area that I just pointed out, which is anything less than -5. Or if you want this to be a true statement, the quantity inside here can be anything in this area, which are all the numbers greater than 5. And so greater than is always solved as an OR case. There will always be two different areas that satisfy the original greater than inequality. Now we go about solving this. We would add 3 to both sides to solve this first inequality, and we would get 2x is less than -2, dividing each side by 2, and getting x is less than -1. Or other solutions would be from solving the 2x minus 3 greater than 5. Again, adding 3 to both sides, giving you 2x is greater than 8. Then finally dividing by 2 on each side to get x is greater than 4. If you put this on a number line, that'll probably help you be much more successful with getting the interval notation, as you will be expected to give these answers for inequalities in interval notation. So if you draw a picture of this, the answers for this problem are -1, and you can put a 0 in there if you'd like. Because this is a less than without a little equal sign, we'll use the parenthesis. Less than would be any value to the left of -1. X is any value less than -1. And then the values from this part of the solution is 4 or greater. Again, that doesn't have an equal sign. Greater than means all values to the right. So this is ultimately what you're going to put in your interval notation. You're going to describe this interval. All values in here are part of the solution set. And you could even try plugging one in. Like for instance, let's say you plugged in -2. The actual endpoint -1 is not part of the solution set. It's just where the solution set starts, which is why it's a parenthesis rather than a bracket. But anything over here all the way out to -infinity, when plugged into the original inequality, will give a true statement, such as -2. If you put -2 in here, 2 times -2 is -4. Take away 3 would be -7. Absolute value -7 is 7, which is greater than 5. And any number that you plug in from this region, -1 to infinity, will result in a similar true statement. Likewise, everything over here satisfies the original inequality. 4 is not part of the solution set, but the solution set starts there. But 5 or 6 or 7 or 8, any of those numbers. How about if we plug in the number 6? That's part of this area. 2 times 6 is 12. 12 take away 3 is 9. Absolute value of 9 is 9, and that is greater than 5. So everything over here satisfies the inequality. So any of these can be checked by plugging in anything from the intervals into the original inequality. And of course, you're going to be expected to go all the way to the point where you state this the graph of the solution set in interval notation. So this would be read left to right as you state your interval. -infinity all the way up to, but not including -1. Or we say or, and whenever there's a gap in between your two solution intervals, we read that out loud using the word or, but mathematically, the union symbol stands for the word or anything from 4 to infinity satisfies the original inequality. And that is your final solution.